But because there were not enough base station, when you are away from the base station, it will use 4G LTE. Automatically cut over the 4G LTE. Alright? So yes, there are products out there. Whether we come in or not, we do not know. 11P is supposed to provide the communications infrastructure for, as I said, V2X. Okay? But now people are still uncertain what will really happen because 5G is being launched, as you know. Okay? So this year, at least 4 or 5 countries are launching their 5G network. Of course, it will not be pervasive, it will take time. Now, then again, how much will it cost? We do not know yet. Right? Coverage will not be as great. So there are all these competing technologies as for market penetration, so it's hard to say. There's also TV white space. We also did a test pilot here in NUS for TV white space. Okay. 3 years ago, we worked with a vendor, Power Automation. Okay, it's a subsidiary of SingPower. Okay, so the pilot was Utown. One of the halls, I cannot remember which one. We equipped the halls with telemetering, so that as a student renting that particular room, okay, you don't pay a flat rate for your utilities. Alright? So if it's an aircon room, then you pay according to what you utilize in terms of your utilities. Alright, so there's telemetering, but this data has to go back to the cloud. So the way they went about back to the cloud was that for each of these rooms, they put in a Wi-Fi router, a mini Wi-Fi router. So we also got free Wi-Fi, free internet. And the Wi-Fi routers are connected using TV white space. Why? Because SingPower and this subsidiary are not telco operators. If they use the telco operators' wireless network, they have to pay. Right? If you use 4G LTE, you have to get a prepaid SIM card or postpaid SIM card, you got to pay. Correct? So they put in this TV white space, which they don't have to pay. It's their own assets, their own infrastructure.
I mean, the signal is via the power.
So, no. It is a wireless technology. Alright? It's a wireless technology, but it's different from cellular, it's different from Wi-Fi. But it can provide long range as well, up to about 5 kilometers. Okay? So that goes into Power Automation's own gateway into the internet. So they don't have to pay the telco. Right, I think I'm coming to the end for this part. So these are the components, the station, this is a station, all right, the AP, all right, and together they form a basic set, as you can see, basic set, the stations and the AP, okay? All right, so this is one basic service set, it's another basic service set, and you can multiple ones, and they form an extended service set, all right? Then you can also have independent VSS. Independent VSS means that they behave on a peer-to-peer level. It doesn't go through a gateway. Okay, it doesn't go through a gateway. All right, and then the APs here are interconnected through a distribution system which can be wired or wireless. So all our APs around here is connected to our MUS optical network. Okay, so that's the distribution system. All right, so these are different physical layers. The MAC layer is here, and it can do two things, either DCF, which is the common mode, or PCF, which is the point coordination mode. This one will give you contention free. Right now, with DCF, you contend because of the RPS, CTS, you fight for each other. Okay, you fight for each other. All right. So in NUS, depending on which department, especially in engineering and as computer science, there are a lot of rope APs. This flat feel like it, they put up and wireless router here. That feel like, hey, put another wireless router here. Alright? So in some of this lab, the performance of your Wi-Fi is horrible. Why? Because there are too many rogue APs around. And everybody blasts as loud as you can. Okay? So in our lab, if you take any of the Wi-Fi analyzer mobile app, there are more than 100 APs in my environment. That's why if you use Wi-Fi in my lab, it's terrible. And they're all very loud. Everybody's shouting. When everybody shouts, you collide. Nothing gets through. Okay? Right. So anyway, that's DCF. Okay, and these are some of the ongoing activities. All right. AX is very active now. Improve the performance in dense scenarios. Okay. Example of dense scenarios. Let's say you go to Suntec Exhibition Center. You know, when they have an IT exhibition, you know, thousands of people there, and they want to do demonstrations in the Wi-Fi. So this is an example of a dense situation. Okay, the Wi-Fi routers you buy for your home cannot use in those places, you know, because the DNS can only give you so many sessions. Right? So you need to take care of very dense situations, and so special protocol must be used, and that's what it's for. Right? So there's another group that's looking at light communications. LiFi. L-I-F-I. Light fidelity. So imagine maybe next time you don't need a Wi-Fi. Some of these slides are actually APs. So they modulate the signal. Enough and fast enough that you cannot see and irritate your eyes. Okay? Right? So some people are looking at that. That's the light communications. And so on. So I think that's all I have right now for media access control. We take a short break, we come back and go into routing protocols. Any questions? Yeah, I'm sorry I'm moving a little bit fast, but as I said, we are a little bit behind. All right, if you want more details, there are all these links that I've given you. Okay, but it's to give you an overview of what's there is out there. Okay, short break. Can I? Is Free Soon here? Free Soon.